This is where we left off in the lesson the other day. We're beginning to talk about the I values. If you have I to the first, it just means I. If you have I squared, it means -1. I to the third means -I. And I to the fourth is 1. A way to look at it is how many pairs of I, how many I squareds will go into this. I have 1 I squared. 1 I squared gets me -1, and I'm left with 1 I. I to the fourth. I have 2 I squareds. 2 is even. An even number of negatives gives you a positive. If I look at I to the 11th, that means I have 5 I squareds in there plus 1 more. Well, if I have 5 I squareds, so that means I have an odd number of I squareds. So I have an odd number of negative numbers. An odd number of negative numbers will give me a negative number. So I have negative, and then I had the 1 I left over. So we have -6I to the 14th. Looking at the I to the 14th, how many I squareds will go in there? What's 14 divided by 2? 7. Are there any left over? No. Is 7 odd or even? So if I have an odd number of negatives, what do I get? Negative. So I actually have -6 times -1 is 6 is your answer. If I have I to the 63rd, what's 63 divided by 2? 31 and something, right? So there's 1 left over, because that's at something. So 0.5, so you had 1 left over. 31, is that odd or even? Odd, so if it's odd, it's going to be -I. If I have I to the 63rd, it just means -I. Try this one. All right, 1/2 I to the 7th. Now, the 1/2 isn't going to go anywhere. If I look at the I to the 7th, what's 7 divided by 2? 3.5. So it's 3 and 1 left over. So there's 1 I left over. Is 3 odd or even? Odd means I have a negative. -1/2 I. If I make this I to the 70th, I have 1/2 I to the 70th. Divide by 2, I get 35. 35 is odd, so it would just be -1/2. If I had I to the 64th, half of 64 is 32, nothing left over, it's even, so it's +1. That's your answer. If you remember, I's have to be a 1 or an I. That's the only things you can get. 1 or an I. You can't get other numbers out of an I. I have 3 plus 10I over 5I. We cannot leave imaginary numbers in the denominator. It's like leaving a square root in the denominator or a fraction in the denominator. It's one of those things you have to simplify. In order to get this 5I, or this imaginary part, from the bottom and move it to the top, I have to multiply by the conjugate. If you remember from a couple sections ago, what's the conjugate of 5i? Negative 5i. It's always the opposite of the imaginary number. What's negative 5i over negative 5i? 1. So I'm really just multiplying the problem by 1. And multiplying something by 1 doesn't change it. The only thing I'm doing is changing the way it looks. So I'm going to multiply the top by negative 5i and the bottom by negative 5i. 3 times negative 15i, or sorry, times by negative 5i is negative 15i. 10 times negative 5i, negative 50i squared. On the denominator, what's 5i times negative 5i? Negative 25i squared. What do I know about I squareds? It's negative 1, so it makes this one here positive 50, makes this one here positive 25. Now, what I'm going to do is put the reals with the reals, imaginaries with imaginaries. So I have 50 over 25 plus negative 15i over 25. Only thing I've done is broken the fraction into two pieces. What's 50 over 25? 2. What's negative 15i over 25? What goes into both numbers? 5. How many times 5 go into 15? 3/5, but it's actually negative 3/5 I, and that is your answer. All right, for this one, I have 3 plus 8i all over negative I. If I multiply by the conjugate of the denominator, which is just I, you multiply by the conjugate, which is the opposite. So 3 times I is 3i. 8i times I. 8i squared. What's I times I? Negative I squared. What's I squared mean? Negative 1, so it makes this negative 8, makes this a positive 1. Now, anything over 1, we usually don't write. So what's your real piece? Your real piece is the negative 8 plus 3i. I have 2 plus 8i all over 4 minus 2i. This one looks different, but you still treat it the same. You have to multiply by the conjugate of the denominator. What's the conjugate of the denominator? Remember, when we're talking about conjugates, you only change the sign of the imaginary number. So I have 4 plus 2i. 4 plus 2i. And what you're going to do is we're going to multiply by the numerator and denominator. So I'm going to have to FOIL. 4 times 2 is 8. 2 times 2i, bless you, 4i. 8 times 4, sorry, 8i times 4 is 32i. And 8i times 2i plus 16i squared. On the denominator, what's 4 times 4? 16. What's 4 times 2i? Plus 8i. What's negative 2i times 4? Negative 8i. And what's negative 2i times positive 2i? Negative 4i squared. So all I've done is taken the conjugate and multiplied by the numerator and denominator. Factored it out. Distributed it. When I have I squared, what does this really mean? Bless you. Negative 1. So it makes this a negative 16. Makes this one down here a plus 4. Now I'm going to combine my like terms. Let's look at the real numbers. What's 8 and negative 16? Negative 8. What's 4i and 32i? Plus 36i. Now in the denominator, what's 16 and 4? 20. What happens here? Why do they cancel out here? Because I have a positive and a negative here. When they're the opposite, remember it's our special function. 4 squared, 16 minus 2i squared gives you the 4i squared. Now I'm going to put over 20 here, over 20 there. Instead of writing it all over 20, I broke it into 2 pieces, because now I can simplify. What goes into both 8 and 20? 4. So if I divide by 4, negative 2 fifths. What goes into both 36 and 20? Not 6, 4. 36 divided by 4 is 9. 20 divided by 4 again is 5. Your answer is negative 2 fifths plus 9 fifths I. All this is simplifying a problem that has an imaginary number in it. Now, this problem, I had 8 plus 4i divided by 7 plus I. And I had you just do the first 2 steps. Now, the first step is to multiply by the conjugate of the denominator, which means you multiply by the same thing but the opposite of the imaginary. So instead of 7 plus I, I'm going to multiply by 7 minus I. And so that I remember that I have to FOIL, I just put parentheses around those also. Now distributing. When I distribute, what's 8 times 7? 56. What's 8 times negative I? Negative 8i. Okay, what's 4i times 7? 28i. And what's 4i times negative I? Negative 4i squared. Now, most of the mistakes that I saw were sign issues. Now, on the bottom, you can decide to multiply it all out or know that this is special. Knowing that this is special, what's 7 squared? 49 minus, what's I squared? Well, it just means I squared. If you would have did the whole foiling, you would have had 7i minus 7i, which they will cancel out. All right, now we go to simplify. First thing I'm going to do is change the I squareds, which makes this I squared, what's negative 4i squared become? Plus 4. The negative I squared in the bottom becomes plus 1. I'm putting the plus 1 so I don't forget I'm adding 1. All right, let's look at the real numbers. What's 56 plus 4? 60. What's negative 8 and 28? 20i. What's 49 plus 1? 50. Now I need to simplify. 60 over 50. Well, I can get rid of the trailing zeros. 6/5. 20 over 50. Get rid of the trailing zeros. Plus 2/5 I. And that's your answer. 2i over 5 is the same thing. (45 minus 3i) all over 7 minus 8i. Coming around for this problem, I saw a lot more people put the conjugate. 7 plus 8i. 7 plus 8i. Now it's the distributing. 45 times 7 is 315. 45 times 8i is 360i. Because it's 45 and I have plus. Now I'm doing this one now. Negative 3i times 7 is negative 21i. Negative 3i times 8i is negative 24i squared. Now in the denominator, because it's the same expression, but the sign's different, I have 7 squared is 49 minus, what's 8i squared? 64i squared. This right here, having an I squared, will make this negative 24 a plus 24. This one here will make this negative 64 a plus 64. Now, what I saw a couple people do is this. They broke it up right now. What's your denominator? 49 and 64 is, and they put 113 here and 113 here. You're allowed to do that. What's your real piece? What's 315 and 24? 339. What's 360i minus 21i? 339i. What's 339 divided by 113? So I have 3 plus 3i. And that is your answer. Any questions?